want to talk about the binary coded decimal code. Okay, so as I explained already, so you have some numbers in the decimal, which is 0 to 9. So in the one side of this table, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so if I just do something like this, I'll separate all of them from together. So you could actually, in these actually binary code, you could actually have a different the codes, and you could represent each of them with the different actually numbers. For example, I actually mentioned a few of them. For example, we have the BCD codes, okay? So here I'm writing the BCD codes. In the BCD codes, you represent 0 with 40. So 1 represent with 1, and 2 represent with 1, 0, and 3 represent with this, 4 represent with this, 5 represent with these 4 bits, 6 represent with this, 7 represent with this, 8 represent with these 4 bits, and 9 represent with this bit pattern. Okay? So if I, for example, if I say, okay, what is the 15 in the BCD? So 15 is in base 10. What is in BCD coding? So it should be easy. You just back to the table and say, okay, what is the 1 in the BCD? 1 is 0, 0, 0, 1. Okay, I use this table. What is the 5 in the BCD? This is 5 is 0, 1, 0, 1. Then you put 0, 1, 0, 1. Okay, so that should be the 15 in the BCD coding. Okay. So similar with this, we have actually some other codes. So I'm writing the most famous one, which is the BCD is one of them. We have actually the XS3, which we represent with XS3, EX3. So in XS3, 0 represent with this. So the 1 represent with this. So 2 represent with these 4 digit, 3 represent with these 4 digit, the 4 represent with these 4 digits, 5 is the 5 is 1 0 0 0, the 6 is 1 0 0 1, the 7 is 1 0 1 0, the 8 is 1 0 1 1, and the 9 is again 1 1 0 0. Again, you could have another example. If you want to do the same thing 15, if I say, okay, write with the XS3 codes, again, that's easy. You just say, okay, what is the 1 in XS3 is 0 1 0 0. So you write 1 1 0 0 for 1, and 5, what is the 5 in XS3 is 1 3 0. You write 1 3 0. Okay. So that's actually is XS3. So we have actually some other actually codes. Again, I just write one more than there is actually too many of them. So I'm write another famous one, which is the gray. Okay. So in the gray, so the first 0 is 4 0, 1 you represent with 1. So 2 is 2 0 1 1. So the next is 0 0 1 0. The next is 0 1 1 0, which is 4. So the next is 0 1 1. So the next is 0 1 0 1. the next is 0120, the next is 1120, and the next is 1101. Okay. So we have the others, which I'm just seeing mentioned to their name. So the table is in the book. You could actually take a look to the book, but the whole actually telling the same thing. Whatever you want to actually write that number in that specific code, just back to this table and see each digit actually write in which way. So then just write that number with that codes that you get from this table. Okay. So the gray plus 3, I don't know, 8, -4, -2, -1, 2 out of 5. So these are the other actually binary coded decimal codes, okay? So again, whenever we ask to do that, definitely we give these tables. So, and you have this table, and using with this table, definitely you could write any actually number in the decimal with these codes that you see, okay? So these are actually was the first codes that we had. So after this, we actually get the ASCII code. So that means whatever you have as a ASCII code. So here with these codes, you just actually cover 0 to 9. Okay, suppose you want to do the same thing, but you want to actually have the code for A to Z, for the letter from actually A to Z, and also the code for cap A to cap Z, okay? And also same thing for number 0 to 9, and also some specific character, right? So like this asterisk, whatever you have on your keyboard, okay? Some actually specific characters. So which is usually the total of them is usually 128. Okay, 128. And we actually use each of them, we actually use one ASCII codes, which is the 7 bits. Okay, we call that the ASCII, which is usually it is actually the 7 bits. Okay. So you tell me, with 7 bits, how many different bit pattern I could make with 7 bits? Because for each of them, you should have the unique bit pattern, similar what we had here. For 0 to 9, we have a unique bit pattern, right? So here in the ASCII, all of them you should have the unique, yeah. 896, if this is 2 power 7, your answer is right, okay? 2 power 7 is the total number of the bit pattern that you could actually make, okay? And each of them should be have the unique 7-bit pattern, so we call that actually the ASCII codes. We have actually some other eASCII, which is the extended ASCII, so usually say eASCII. So which is, first we had the ASCII, then you see, okay, this is not enough, we want to have some more sample on the keyboard, then they actually make the eASCII, which is actually use the 8 bits, not 7 bits. So the eASCII actually use the 8 bits, and each element in this eASCII actually represent by 8 bits. Okay.